Howdy, I'm Pragati Armugam Kumar, and I'll get started with Milestone 4 for the course Advanced Data Management. And today's table of contents will be as listed below, and I'll explain cluster performance. So, until Milestone 3, we have implemented various DB architectures, which is a single node architecture and standard replication architecture and 3-node Galera architecture. So, my motivation for today's cluster performance comparison is to compare the performance between single node and 3-node Galera cluster architecture, and I will be doing that by utilizing the following three commands, which is explain, show global status, and MariaDB monitor. And I will explain the performance metrics code for the same. So in order to do this, I'm first creating an heartbeat SQL command, which will basically insert infinite rows, insert operations in my heartbeat database. So I will execute this in one of my Galera cluster node. So as you can see, this is my Ethermat Galera cluster 1 node, and I will paste this code. So this is a while true operation, which means it is going to get executed infinitely, and this insert operation is going to get inserted infinitely until a user interrupts it. And yeah, the insert has been started, and I will go ahead and I will start performing the performance metrics codes. So I will first execute the MariaDB monitor code, which and in order to perform this is a prerequisite, which is we have to enable performance schema, which is by default off, and I have to mention it as on in my conf 50 server CNF file, and then restart my MariaDB. So I have already done the prerequisite, so I will go ahead and directly execute this code into my MariaDB terminal. And you can see these are the outputted results, and these results are nothing but the SQL commands that has taken a lot of time, which has basically used a lot of resources, which might be time or CPU or GPU resources, in order to get executed completely. And you might see most of the commands are based on the MySQL, or all the system commands has been given here, except few commands. For example, you can see this is one of my ethermat command where I'm performing multiple join operation and then retrieving the result. And this is the average sum which has been utilized in order to perform this execution, and this is 0.002, which is milliseconds, but even it is millisecond, in real time it is a considerable overhead. So now, since this command is causing the bottleneck for my scenario, I will go ahead and I will utilize the explain performance metric to get a more better picture of what this code is doing and what are the resources that this code is utilizing. So this is my exact SQL query, and I'm performing an explain command on this query. So I should first select my database, which is Ethermat, and then I will execute this query. So you can see, basically this view query is using 5 different tables, which is order item, orders, customers, products, and categories. And all these tables are being referenced, and 4 of these tables are being referenced by foreign keys, and order items is the base table that I'm performing the view from. And since it is the base table, I'm first comparing against 24 rows. So in order to arrive at a particular order ID, and then for each, and then these 4 are referenced in foreign key format. So foreign key, every primary key has indexes created corresponding to it. So when I access a row with an index, I just need one hit to retrieve the data. So on a whole, I'm utilizing 24 plus 4, which is 28 number of row executions. So this might be very simple since the data is very less for me right now. It is a small database, but in real-time scenario, this will cause enormous overhead. So when in the future, if I want to optimize this query, this is where I should exactly focus on. So this is the gist what the explain query is giving to me regarding this view creation statement. And then I will also execute this show global status query. So show as of now we have seen the status, we have seen the performance of a single query, single Ethermat based query. Now the show global status query will give us an overall picture of what the EC2 instance is occupying. So I will execute this. And as you can see the code, I am encapsulating this show global status SQL query, MariaDB SQL query inside a watch-n2, which is basically the data is going to get updated for every 2 seconds. And I will go ahead and execute this. So you can see the total number of insert operations, select and update operation I have performed so far in this database is listed here, 285, 36, and so on. And since I have performed no update operation, it is 0. And you can see this data is constantly changing because I am constantly inserting data through this heartbeat command. So that is why this data is changing, since for every 2 seconds I'm updating this metrics. And then the number of threads running is currently one, because I have performed no multi-threading operations in here. It is direct single node, single insert operation that is going on. And slow queries is, as of now, it is zero, since the insert operation that I'm doing currently is very simple, which is basically directly inserting a data. And yeah, and also you can see there is no InnoDB row logs, because there is no multi-threading going on, and then there is no rows that is being logged. So this is my overall gist of the EC2 instance metrics, performance metrics of the Galera DB cluster. So I will go ahead and continue with my presentation. After performing this analysis, I have come to a conclusion that when there is a lot of write operations going on, Galera cluster is giving me a better performance, whereas there is only a multiple read operation going on. In that case, there is depending on the use case, it depends if single node cluster is better or Galera cluster is better or not. And then I'm proceeding with the advanced ETL pipelining. So I have performed a multi-stage transformation of EL, TL, TL, which is nothing but, for example, if you take the customers table, first I'm extracting the data from the CSV, and then I'm loading the raw data into my customer staging table, which is my first load. And then I'm performing my first transformation of standardizing the data and performing clean operations. And then I'm storing all the cleaned data into the customer's prod table. And then after performing that, I'm loading the data into my customer spot table. And then my second phase of transformation, which is basically I'm performing a few analytics. I'm performing aggregate operations or enriching the data, and then I'm performing few analytics, and then storing the data into my views. So I'm performing multiple stages of transforms and loading. And I have also ensured data atomicity, since the suppliers table, which I'll be discussing in the next slides, was not atomic, and I have performed atomicity in order to comply with ACID properties and first normalization. I have performed stored procedures and triggers to implement to automate the whole ETL lifecycle pipeline. And then I've used partitioning and indexing to improve the query performance. And I have also used column store for these analytical databases that I'm creating. And I've also used atomic transactions in order to guarantee data integrity. And I'm also creating audit tables to store all the logs corresponding to the update and insert operation. And I'm storing all the data into the views and virtual columns for analytics. So now I will show you the script that I'm using for performing this analytics. So I'm creating a database called Ethermart, and this is the base Ethermart, and I'm creating staging tables for all the 7 core e-commerce Ethermart dataset. So as you can see, my staging table has only varchar. So except for the key IDs, I'm using it, and for all other data, I'm using just varchar, because I am not performing any kind of data cleaning or data processing in the staging table. I'm loading all the raw data as it is. So as you may see here, all my staging table will have only varchar. So once all these staging tables are created, I am performing load operation, which is basically I'm reading the data from the CSV, and I'm loading all the data directly into my staging table, including the IDs of the data which is stored in the CSV. So I'm even preserving the IDs, and then moving ahead. And now next I will be creating the corresponding prod tables. Now we are coming to the actual table where the cleaned data is stored. So here you can see, for example, in the customers, I'm creating columns based on the corresponding data type. For example, registration date is a date data type, so it is date. And I'm also ensuring not null constraint for the required columns. And I'm also giving key references, which is primary key references in this case for the customer ID and state. And I'm also performing partitioning based on the region of the customer in order to improve my query efficiency. So similarly, I'm doing the same for a few of the other tables as well. And one key thing to note here is initially in the CSV, supplier table was just a single table, but then I am creating 2 tables for the suppliers, because the contact email in the supplier table was not atomic, as in the contact email of a single row corresponding to single row and column had multiple comma separated emails in it, which is not atomic, and it does not comply to the first normalization form of the database, and thus fails to convey ACID properties. So in order to resolve this, I'm segregating the contact email column into a different table, and then I'm storing every individual email ID in a separate single row, and then I'm referencing the corresponding supplier ID to the suppliers table, so that by this way I'm ensuring ACID compliance. And then moving ahead, I am doing the same. I'm creating the prod tables for products, orders, and in the orders I've also created partitions for partitions based on the time range in which the order has been placed. So I'm comparing the year of the order date, and then I'm creating orders, and I've also created indexes for this order ID based on the based on the customer ID foreign key column. I'm creating an index on orders for faster retrievals. So moving ahead, yeah. So over here you can see I've also created an audit table. So audit table is basically for me to reference all the transaction that has happened in case if I face any bugs or anything. So this audit table will contain the detail about the table name and the record ID and the old and new value that has been performed. And this is the store procedure in order to store the data into the audit table. So I'm storing the data in audit table for products and order updates. So in case there is an update operation happening in products, so I'm comparing the price of the new and old. And if there is any change, I'm logging the corresponding log into my audit table. And then similarly for orders, if there is any new order being placed, then for after insert on orders, for every new insert, I'm basically logging the corresponding order into my audit table as well. And in the products table, one more thing that I wanted to let you know is, okay, we are moving ahead with the store procedures for cleaning cleaning all the data from the staging table. So now I have the data in my staging table, and I'm performing store procedures in order to clean all those data. So as you can see, this is one example. I'm cleaning the data of the customers table. So you can see I'm performing an insert into operation into my customers, not customers staging. I'm performing into customers and reading the data from the customer staging table. And then while inserting, I'm performing a minimalistic data pre-processing, which is trimming all the string data, lowering the email, and then standardizing the date format into one particular format, which is year, month, and date to perform uniformity. And also I'm performing basic constraints such as email should be in this regex and registration date should be less than current date and name should not be null. So these are the basic constraint checks that I'm performing before standardizations that I'm performing before inserting into actual tables from the staging table. And then proceeding ahead, and then I have performed the same clean operations for all of my. So starting from a customers table, I'm doing the same for my categories table and suppliers table and products table and everything. And in the products table, one more thing that I have implemented is I have ensured that all of my insert operation is encapsulated into a transaction. So you can see I'm starting the transaction and then I'm performing all the insert operation, and then I'm ending a transaction and committing all the data here. And in case if I face any failures, I'm rolling back the transaction to the I'm rolling back the transaction here, giving a error to the user that the transaction has failed, and the data that has been entered into the table will also be rolled back. So on a whole, if this insert operation executes, it will execute on a whole. If it fails, then all the data inserted will be rolled back so that there is no inconsistent data or incomplete data left in the database. So yeah, moving ahead, I'm doing the clean operation for every single table. I'm ensuring the date, etc. And yeah, so once all the stored procedure for every table is created, I'm calling all the stored procedures to execute the pipeline to move on to the next stage of clean. And then this is the phase where I'm performing the next second stage of transformation and loading, where I'm creating a view. I'm performing few analytics and then storing it in the view. So for example, this is a daily sales analytics view. So I'm creating a table called daily sales summary, and which is of the type column store because it is more efficient for analytical database. And then the columns here is like total revenue, total orders, and total units based on the date. And then this is the corresponding procedure which will store the data into my analytics data. So the definition of this procedure is basically insert into my daily sales summary table, where I'm querying the data from my by combining two tables, which is by combining orders and order item table. I'm performing some aggregate operations, which is some count, and then I'm storing it based on the date. So yeah, similarly, I'm performing multiple other views for multiple other analytics. For example, customer lifetime analytics, and then the product level sales analytics, etc. And so on. So this is my milestone 4 script. And now I will go to my cluster and then I'll execute this milestone 4 script for you to have a better idea. So this is my Ethernet single DB cluster. And then I have already loaded this milestone 4 script here. So as you can see, milestone 4 has the same code that I showed you now. So I will execute this MariaDB code here, milestone 4. So once that is executed, I will be printing the number of rows created in each table, which is in order to have a better view, I'm just printing the number of rows, not the exact data. So until this, these are the data, actual prod data, and the number of rows in the prod data. And from here, this is the analytics view that I created and the number of data in these analytics view. And I will go ahead and I will display one of the analytics view, which is daily sales summary, which I just explained to you now. So I will display that. So I have to use my Ethermart database. And once that is done, I will perform a show select operation. So in the select operation, I will, as you can see, it is displaying all the total revenue, total orders, and the total units that has been placed on a single date, which is here. So similarly, I have performed other analytics as well, which is stored in the corresponding views. So this is my robust ETL pipeline where I have ensured that I am extracting data, loading in staging table, so none of my raw data is lost, and then transforming, which is I'm standardizing the basic data and storing it in the prod table, and then from that I'm transforming, which is I'm performing few analytics and storing it in the views. So this is my multi-stage ETL pipeline, and then proceeding forward, vector embedding and similarity search. So in order to perform this, I have used text embedding 004 for library, which will help me to convert the text into its corresponding numeric vector, capturing all of its semantic meaning as well. And all these embeddings are stored in my database in the JSON format or in its native vectors format. And I'm using vector underscore from text in order to convert the user entered prompt into vector embeddings. And also the query text is embedded with the same, which is text embedding 004 library, which is same as all the other embeddings, so that I'm maintaining uniformity between the prompt conversion, prompt vector conversion, and the data in the database from vector conversion. And I'm using vector underscore distance function to compute the similarity between the user given input and the existing database input to query results. And I'm ranking the results based on the similarity index that is written, and I'm returning the closest top values. So I will go ahead and also AI data preparation. So for the AI data preparation, my whole database, I have performed a proper data pre-processing system where all the data is pre-processed using database triggers which have been automated. And then these pre-processing includes cleaning the data and standardizing the data to ensure uniformity and prevent any noise during embedding data generation. And then I'm also using AI AI, which is Gemini in my case, to generate product description for the product table. And then I'm feeding this product descriptions column as in vector embedding so that the user can search for a product in their own natural language. And I'm in also customers table. I have implemented a new column which will merge the existing columns in order to describe about the customer, and I'm storing it into a virtual column. And then I'm sending this into the vector database, which I'll show in detail in the forthcoming slides. And also, altogether, these refined data will help me get a content-rich vector, which will enhance my similarity search. And I've also created a vector index, which will also help me optimize fast retrieval of all my similarity index searches. And I will dive deeper into this. So, so this is my this is my Jupyter Lab code, which Professor G gave to us. And in order to perform this script, in order to run the script, we need a .env file. And my env file is here. And this will require my Google API key. And this is basically my nodes public IP address. And these are my database configurations, Ethermart and student database configuration. And I will move ahead. And in order for my Python script to connect with my EC2 instance, I should perform one more step, which is I should update my security configurations inbound rule to include the 3306 port as well. So as you can see, I have added this SQL port range into my inbound rules, and the source is 0.0.0.0, which will allow basically any network traffic. It doesn't restrict anything. So now I will go ahead to my Jupyter notebook, and I already have my .env file. And then I'm going ahead. So I have performed vectorization for three tables, which is products, customers, and reviews. First, I'll show the products table. So for the products table, I want to do two key operations, which is generate a description for the product based on product name, and then perform vectorization. So this is the code for generating description, and these are the prompts that I'm going to pass into my Gemini to generate a description. I'm taking in the input as product name, and then I'm going to perform these. I'm going to input these prompts into my Gemini to retrieve a description based on this prompt and product name. And then this is the loop which will help me generate the product description. I'm calling the generate content model. I'm passing the prompt, and then these are the security configurations, which is basically helpful for us to prevent any harmful contents. And these are the prompt generation configuration parameters here. And once that is done, I'm returning my generated prompt, and this is my main block. So in this main block, I'm executing an update query, which will basically update my products table and set the description and embeddings to the corresponding value that I will be generating below. And as you can see, I'm basically executing a select operation of all the products where the product description is null. So that if the description is null, I will generate the description and then corresponding embedding. So this will give me the list of products, and then I'm looping into those products, and then I'm generating its corresponding product description through the method I shown above. And then once that is done, I'm calling my vectorization function, which will take inputs the embedding model and the product description. So with these two, this function will create a corresponding vector for the data, and then which will store into product vector. And once that is done, I'm executing my update query, which I showed above, which is basically going to update my products and going to set the description and embedding based on whatever values that is returned by the corresponding functions for the corresponding product ID. So once this is done, as you can see, I have executed this already completely successfully, and you can see no products found that meets a description anywhere. So I'm going to go. Now I will move ahead with the reviews database. So for the reviews, I'm going to utilize the same piece of code, but I'm going to skip the part where I'm generating description, because in the reviews table, we already have a column called reviews text, which stores all the reviews entered by the user. So this is my main block of code. You can see I'm performing a select operation from the reviews table, where I'm retrieving all the rows where the embedding is null. So this is really important. I'm not retrieving the rows where the review text is null, because we don't have to generate anything, but instead I'm retrieving where the embedding is null, and I'm going to loop on through the same through the retrieved result set. And over here, you should know that I have commented the generate description function. So I'm not generating anything using Gemini. Instead, I'm just passing in my review text column into my process with the retry function, so that it will execute and give me a corresponding vectorized form of these review text. So now the vector embeddings is stored in the product vector, and then I'm calling my execute command for the update query. So this update query will basically is nothing but this, and it is going to update my reviews table with the embedding set it as the one that is being retrieved by my process with retry function for the corresponding review ID. And as you can see, I've already executed this, and there is no more products left for me to execute the same. And then now I'm going to perform a similarity search. So over here, the query that I'm going to give is positive. So for this, positive is the user input, and the command that I'm going to use is select review ID and review text. And then the special part is here. I'm going to perform a vector underscore distance function, and I'm passing the embedding, which is my whole review text column embedding, and going to compare it against my user entered input, which I'll be passing this question mark as user entered input over here. So that the prompt, the user given input, which is positive, I'm going to compare that positive against all my embeddings, and I'm going to calculate the distance, and then I'm ordering the whole retrieved result by distance, and then I'm retrieving the top 5 results. So now I will get the most top 5 common similar indexes, and you can see the result is being printed below, and you can see the similarity index, which is 0.66, 0.606, 0.55, and these are the most similar one to the positive command. And then moving ahead, I'm going for my customers database. In the customers database, I have implemented a separate extra step, which is basically I'm creating a new column called profile text. So I have noticed two key things here. So my customers table is a plain table which has individual columns, like as in atomic columns, as in names, locations, and date, registration data, etc. So this doesn't have any contextual meaning for me to pass into the vectorization. vectorization. So first I have to create a new column which will have a sentence format of all these data combined together, which is what I'm doing through the concat operation here. And then I'm passing this more meaningful, more contextualized data into the vector database. And also, initially, I tried to perform the same in my customers table, not the customer staging table. But then, since my customers table has partitioning, this I am not able to perform vectorization. So that is one of the key disadvantage. We will not be able to perform vectorization in tables which has partitions. And thus, I did the same with customer staging table because it doesn't have any partitions. I added this new column, and now in the code, as you can see, I am going to use this customer staging table. And yeah, this is my main piece of code. I'm going to first retrieve all the customers where embedding is null, not so this is same as review text. I'm not going to generate anything. I'm just going to generate vectors for the text that I already have. So for the rows that has embedding as null, I'm going to retrieve it, and then I'm going to loop through the results it, and I'm generating the vectors using this function and passing in the profile text, which is the generated column that I just created now. And then I'm passing this as an input, and I'm creating vectors corresponding to that. And once that is done, I'm executing this update query, which will update my customers table with the embeddings for the corresponding customers. So once that is done, as you can see, I've already executed this and there's no more customers left for me to update. And I'm going to perform a similarity search. So I'm going to search loyal long-term customers. And you can see that I am here. I'm going to I'm going to retrieve the customer ID, first name and profile text. And I'm going to compare the distance between embedding and the user inputted text. And as you can see, the result is as below. Since the text is loyal long-term customers, it is retrieving all the customers that dated back to more than a year, which is like from 2004, 2024, 2023, etc. And these are the similarity indexes for the same. So this is how I performed vector embedding and similarity search. So regarding AI disclosure, I have primarily leveraged ChatGPT and Gemini to debug errors while I was performing vector embeddings, and I also used it to double check the security group configurations that is needed to communicate both my Python code with my EC2 instances. And I've also used AI to generate flowcharts, which is used in this PPT. And the limitation that I encountered, what AI outputs depends heavily on the user entered prompt. So if I miss any crucial details in the prompt, then the output that AI gives is not readily usable for me in the code. And also the reflection is we can get best results out of AI when we combine our solid understanding of the underlying concepts with AI given results. So if we use AI given results as an add-on, then we will have the best results. But if we completely depend on AI, then we might end up wasting a lot of time or resources. So these are my conclusions, and thank you. This is the end of my presentation.